Hi, my name is Caitlin Swan, and today I'm going to go over the IVT, which stands for Intermediate Value Theorem. Basically, this is a big, long, fancy-sounding theorem that is not as crazy as it sounds. The official little thingy says, when the curve is the function y equals f of x, which is continuous on the interval ab, and w is a number between f of a and f of b, then there must be at least one value c within ab such that f of c equals w. It sounds very confusing at first, but this graph really helps. So the theorem says that when the curve of the function is the function y equals f of x, that means that basically when we're looking at this, whatever this may be, and it is continuous on the interval ab, so there's no breaks, it keeps going from a to b, and w is a number between f of a and f of b. So up here we have w, it's between f of a and f of b. Then there must be at least one value c within ab such that f of c equals w. Basically, in a real problem, they're going to give you a function like this and an interval to look at, which will be your ab, and then a number. Usually it's like f of c equals 1 or f of c equals 1/2. And basically, you have to make sure of two things, and if those things that they say are true, then your IVT is going to guarantee that there is a value c within AB such that f of c equals w. It still sounds confusing, I know, but I'm actually going to walk through a problem to help it sound less crazy. So this is our problem. Consider the function f of x equals 1/2 x squared minus 1 on the interval of 1, 3. Find the value of c guaranteed by the IVT so that f of c equals 2. It sounds crazy, but it's really easy. There's just 3 steps you have to follow, and those are right here. Our first step, we're going to check that the function is continuous on the interval. This is just something you have to kind of memorize. There are 4 different rules. The first rule says that polynomials are continuous at every real number. So as long as you're not looking for an I or something like that, your polynomials are always going to be continuous. Your rational functions are continuous wherever the denominator is not equal to 0. Your absolute value functions are continuous at every real number. And your exponential, logarithmic, and trigonometric and radical functions are continuous at every point on their domain. So our function over here is 1/2 x squared minus 1, and that is a polynomial function, which means that it is continuous at every real number, and our f of c is 2. That is a real number, so we're good. Rule number 1, we are continuous on this interval. So we can move on to rule 2. Make sure that the f of c is between f of a and f of b. Well, our f of c is 2, and our f of a and f of b are going to be what we get when we plug 1 and 3 into our function. So I'm going to go ahead and do that. When we plug 1 in, we get 1/2 of 1 squared minus 1, which is negative 1/2. And when we plug in 2, we get 1/2 of 2 squared minus 1, which is 4, 2 minus 1, it's 1. Yeah. So, no, sorry. This is a 3. So that's actually 1/2 of 9, which is 4.5 minus 1. You get 3.5. So we have -1/2 and 3.5. So we had to make sure that f of c was between f of a and f of b. Our f of c is 2, and that is between -1/2 and 3.5. So we come back and rule 3 says write a sentence. So our sentence is going to say something like, because f of c is between f of a and f of b, and f of x is continuous on the interval of 1, 3, therefore the IVT guarantees a value of f of c. And that's pretty much all you have to do to solve an IVT problem. That's all they want. So it sounds crazy at first, but it's really not that hard. Thanks for watching.